The beach environment and its variation during geological time. The beaches and the barrier islands are long and narrow sand accumulations, occurring within the deltas, along the depositional strike from deltas or in an oceanic or lacustrine context, without any relationship with the deltas. Both the depositional systems are aligned parallel to the shoreline. The beaches are attached to the land, while the barrier islands are separated from the land by a shallow lagoon and are often dissected by tidal inlets. The formation of the beaches and of the barrier island systems includes a steady supply of sands to the shoreline, river input, longshore drift, and a hydrodynamic setting characterized by low and moderate wave energy but a limited tidal range. The beaches and the barrier islands have been constructed by the wave processes, which have been intensively studied through direct observation, experimentation, and theoretical procedures. Regarding the wave processes controlling the beaches, the first process to be discussed is the wave transformation, the second one is represented by the wave-induced nearshore currents, and the third one consists of the temporal variations in the wave regime. The major storm events have the role to control the landward retreatment or the local breaching of the eolian dune ridge. The beach includes a variety of sub-environments, including the eolian sand dunes, the backshore foreshore, and the shore face. In particular, the eolian sand dunes form complex ridges, capping the beach face above the mean tide level and resulting from wind reworking of sands emplaced in the upper beach by the storm waves, attaining a height of several meters. The backshore represents the supertidal part of the beach, which is flooded during the storm events, whereas the foreshore represents the intertidal area. The shore face is the subtidal part of the beach, starting at the mean low tide level and terminating at the fairweather wave base. The role of mangroves in coastal sedimentation. In the coastal protection, the root systems of the mangrove forest trap sediments flowing down rivers and towards the land. This allows to stabilize the coastline and prevents the erosion operated from waves and storms. In the areas where the mangroves have been cleared, the coastal damage from hurricanes and typhoons is stronger. The role of mangroves in the coastal sedimentation has been deeply studied. Alongi has studied the carbon sequestration in the mangrove forests. The mangrove forests are highly productive, with the carbon production rates which are equivalent to the tropical humid forests. The mangroves host more carbon below the ground and have higher carbon mass ratios than the terrestrial trees. The most of the mangrove carbon is stored as large pools in the soil and dead roots. Moreover, the mangroves account for only approximately 1% of carbon sequestration by the world's forests, but as coastal habitats they account for 14% of carbon sequestration by the global ocean. Banerjee et al. Have studied 4 sediment cores from selected locations of the Sundarbans mangroves and Hooghly estuary, northeastern coast of India, to reconstruct the 210 petabits geochronology and to individuate the trace metal distribution in the sediments. The mangroves of India account for about 5% of the world's mangrove vegetation and are spread over an area of about 6,740 square kilometers. The region of Sundarbans hosts the 10% of the mangrove forests in the world and a half of the total area under mangroves in India. The Sundarbans mangroves and the Hooghly estuary have received a considerable pollution load from anthropogenic sources such as the industrial, the domestic, and the shipping activities in recent times, suggesting a high concentration of metals in the top few layers. The obtained results have suggested that the variation in trace metal content with depth or between mangrove and estuarine systems derives from the metal input due to the anthropogenic activities rather than to the diagenetic processes. Blasco et al. Have examined the mangroves as indicators of coastal changes, studying in which way these ecosystems have been used as indicators of coastal changes or sea level rises. These ecosystems are specialized, and any minor variation of their hydrological and tidal regime controls a noticeable mortality. The mangroves are highly sensitive to the inundation regime. If the tectonic, sedimentologic, and hydrological events have been modified, these species tend to readjust to new environmental conditions, or alternatively, they tend to succumb to unsuitable environmental conditions. Perhaps, the use of the remote sensing data for the mangrove ecosystem represents a good tool in the coastal monitoring. In this course, the role of mangroves in the coastal and estuarine sedimentary accretion of southeastern Asia has been discussed. In fact, the mangroves provide also characteristic mechanisms in order to trap the sediments and to accelerate the land building processes in the tide-dominated coastal and estuarine environments.